the slow truck in this heavy traffic. So the model predicts the trajectories, also predicts the whole world interaction, and then evaluate the best decision under the scenario and make the best choice. All this happening like through our efficient visual COT. Yeah, next slide. Yeah, word model is also very powerful and is used in the simulation cases. So we grow our simulation scenarios from 30,000 from previous year to 500,000 scenarios for today. And with this large suite of simulation data, we are accumulating more than 30 million kilometers of the like simulation driving test. So this is much more efficient than the like real world like actual testing cars. So it's a huge game change. And in this example, we can see there are fast VRUs driving ahead of our AV, and we simulate different appearance and different speed of the motorcycle and to interact with our VRA model. Next slide, please. We also use the word model for self-play and also reinforcement learning. And the VRA model predict the future actions of our AV, and the word model predicts the whole scenarios based on the actions the AVs make. So we train the model to iterate itself and to perform better and better in the simulation scenarios. And this also unblocks our opportunity to do the long sequence temporal reasoning. And so our model is iterating and keep getting better through this self-play approach. Next slide, please. The word model is also play a critical role to help us grow to the global expansion, and we do not need to rely on the real data collection vehicles across many countries, many cities to for the target domain, and we can actually rely on word model to generate. For this example, we generate the snow-covered road in Sweden, and we can see the generated video input is highly realistic, and we use the simulation data and for adapt the domain gap for train our VLA model for the global versions. And yeah, next slide, please. Yeah, this concludes my presentation about the second generation VLA. So the key components for the foundation model is three parts. The first one is a large scale model and also a huge amount of training data. And finally, we also relies on the very powerful GPU clusters, a lot of training compute resource to make it together to build the solution for the next generation of the VLA model for autonomous driving. And next slide, please. Yeah, so we are doing we are making the best autonomous driving in China, and we are really proud about our work, and we really looking forward to work with you guys, and like really looking forward to collaborate with you in the future. Now let me welcome Jian from director from Robotics Center to introduce humanoid robot from ESP.
Thank you, Han. Exciting. So we are so proud of the amazing work, the self-driving team and all the people who contributed to VLA 2.0. And we are happy for them. So as a representative from Robotics Center, today I would talk about some interesting things happening on our robotics work. The reason why I say some interesting things, because today I'm not going to talk about some technical details. I know a lot of you here, audience here, are expert, but instead, I'm going to talk about something you might not have much experience in school. Instead, that's very important in industry, which is about some challenges we encountered during the journey of massive production. Next, please. Sorry. Okay, yeah. Before talking about those things, please allow me to introduce myself. My name is Jian Yao. I'm the director of engineering AI. So I got my PhD in University of Toronto AI Lab, and my previous experience was in NVIDIA and Apple. I used to work on self-driving, the AR/VR device, and now robot. Okay, next, please. So first, let's take a minute to look at the timeline of critical milestones on the way we build our robot. We start from the doggy shape robot and then llama shape. And in 2024, we deliver the first generation of Iron. And 2025, as you might see from social media last year, and people actually, there are a lot of discussion in social media whether, there's a person inside the skin of our robot, right? So here we go. Next, please. Let's watch a video. Well, this is like a trailer of a movie, huh? So this is our second generation of XPENG Iron. So here we listed like some of the important update of our hardware components. You can see we use the high fidelity biometric structure, the advanced soft body system, and etc. So next, please. So based on this kind of like a great hardware components, what are we trying to build? So the message is very clear. We want to build the most human-like humanoid robot, as I mentioned, as you can see from the title. So when we say, okay, we want to build a human-like robot, so what defines human-like? We not just want our robot to walk like a human, for example, the catwalk as you saw. And we also want like the robot to communicate like a human. Here, I use HRI, like human-robot interaction. We also want the robot to interact with the physical world like a human. So here, as I just put here, manipulation. So please next. And like last year, AI Day, our CEO, Xiaopeng, he mentioned like by the end of 2026, XPENG aims to achieve large-scale mass production of high-level humanoid robots. So this is a very, very challenging task. Suyuan just earlier, he mentioned, yeah, self-driving is very challenging. Everyone knows that, but building a robot, I don't think any company or any party or any groups of engineers has this kind of experience. So this task is even more challenging or even like exponentially more complicated. So please next. And these days we see a lot of demos from social media say the robot can cook for you, can fold the clothes for you, or can do a lot of cleanup for you. A lot of people feel like, okay, it seems the robot will come to our life very soon. But the reality the reality is not that. So the reality is a little bit bitter. So demo is a demo, and when we want to convert like a demo to a product that our customers is willing to pay out of their pocket, that's not equal, right? So this is actually I just visualized like the difference using an image generated by OpenAI ChatGPT. Please next. So the first challenge here I would love to talk about is reliability. So when people pay for their hardware, right? So of course they want their the hardware they bought to be reliable. For example, when we buy a car, we want our car to run without like without much maintenance and run very well, like through 10 years, for example. So here the same thing. So though the robot, industrial supply chain is not that mature as the mobile industry, but still, like people want to pay their money and they want to get some reliable hardware, right? So we want every single hardware component in our robot to function well, have like very reliable, and also as a whole, we want the robot as a whole to function reliably. And this is the hardware. For software side, same thing, right? So our robot can be deployed in, for example, in indoor or outdoor, like the factory outdoor. So we want our software to perform like consistently well under all these kind of different conditions. And also it can be tested by the time, right? It cannot like just run for 10 minutes and done. Okay, next. So the second challenge I want to talk about is the usability, right? So these days, I'm not sure how many of you, like when you buy a phone or you buy a car, will you just read the menu? I don't think so, for myself at least. So I'm not gonna like read the menu of the iPhone of the phone or the car to like learn how to drive or how to use the phone, right? So same here. When we deliver the product, we just want to minimize the effort the robot can be used by our customer, right? So here, it's not just about the UI. It's also about, for example, when you open the box, the robot can learn the environment by itself. The robot can, for example, self-calibrate all the sensors by itself, right? So yeah, this is about usability. Okay, next, please. So the third challenge I want to talk about is on device computing power. So Suyuan earlier he just talked about, okay, when we deploy large models to the device, there are a lot of challenges, right? So for example, you cannot just simply use the open source large language model. The softmax is not very friendly, or the activation function is not that friendly, right? So we have to solve all these problems. And also, the on-device computational power is very limited. It's not like the cloud computers or even your desktop, right? So we want, and also robots, there are more large models than the car. For example, we have the human-robot interaction large model. We have the manipulation large language model. We have the brain, the robot brain large model. And we have navigation, of course. So when we put all these large models together, right, this kind of limited computational power will be a bottleneck. We have to solve it. And yeah, the Suyuan already covered like a co-design software, hardware to fully leverage on device computation. So here we work very closely with our self-driving team, with our other relevant teams together to solve this problem. Okay, next, please. Okay, the fourth challenge I'm going to talk about. So I'm not sure how many of you are working on robotics. So for robotics, the data scarcity is really a problem, right? So earlier people use teleoperation data to overfit some manipulation or some models on robots. But this teleoperation data cannot scale up, right? It's expensive, it's time consuming, it's just not easy to get. right? So robot is not like cars, right? Every day we have millions or even billions of cars on the road. We can simply get data from those cars. But robots, it's like chicken egg problem. Right now we don't have mass production, and how can we get those data easily, right? And people have to think of either some new way or some cheap way to get more data, or people have to think of some novel algorithm to leverage data across different platforms or even across different modality. For example, we try to use the data from AR/VR device, right? Those data actually are reflecting the 3D scatter or the gesture from real people, right? So we are also trying to leverage the data on internet, those kind of people egocentric data, right? People do, for example, cooking, people do cleaning up from egocentric view. So all these things, we are trying, other methods we are exploring to solve the data problem. Okay, next, please. And next challenge I want to talk about is safety, right? So we all know, in cars we have AEB functionality, right? In this AEB is really helpful. It can save people's life in emergency. And safety is not just about the AEB. So when we deliver, and here is another example. So car usually is operating in public space, right? But for robot, you might deploy it in your personal space, right? So maybe not home, but even in our dealership or in the factory, we don't want our data to be disclosed on the cloud or to be seen by some strangers who are not authorized, right? So we also want to care our customer concern about the privacy, right? So, but the good thing is most of critical things are IID. So basically identifiable. So IID means those kind of confidential information or personal information. Most of these things will be in our own device. So this is about safety. Okay, please next. Okay, so this is another challenge you might not know that much in school. So thermal and battery, right? So we know, or as you can see, our robots are covered by we call it skin. We're covered by a skin. So and also there are a lot of models running on our in-house chips. That means the thermal is really a big issue, right? And there's in robot application, we have some always-on functionality. This always-on functionality means those models have to run all the time, right? So this actually is very challenging. It's very challenging when all these kind of models are running and also the robot is covered by the skins when we talk about the thermal. So besides the battery, so we want our robot to be last or to be operating for enough time so that the use case is well supported. So even though actually, just for your information, our robot can charge itself. So but still, we need the battery to support as long as possible. Yeah, for better use. Yeah, for user experience. Please next. Okay, I want to conclude this talk about using these 3 points. We are building the humanoid robot Iron, the most human-like robot that moves, communicates, acts like a human. So right now there are a lot of challenges in the productization effort, as some are discussed. And with the goal on our roadmap, we will work together with our cross-functional teams the self-driving team, and also maybe some of you to resolve all these kind of challenges to make this happen. And next, please. We hope you are interested in robotics, and if you are you have background of like, for example, motion control or CVML, yeah, you are very welcome to apply for some positions in robotics center. Thank you. I will hand it to.
Yep. Thank you, Siwan, Hang, and Jay for sharing an amazing detailed presentation. So we will take 15 minutes for Q&A session. I see a lot of people posting interesting questions here. Before we start answering questions, I would like all of you to start scanning this code. So this code will make you enroll into the raffle that we'll be doing at the end of the session automatically. Please make sure to give your first, last name, and also email ID. So the gift card will be sent to your email address in 2 to 3 weeks. I repeat, please scan this QR code for you to enroll in the raffle that we'll be doing in a few minutes. I'll get started with the questions. So maybe I'll put Siwan in the spot to start with. Most of the questions were related to VLA 2.0. I think when we were sharing the traffic situation or the ambulance situation, they were saying how does the model differentiate between commuter signs versus police sign, and also how do you make sure it's actually responding to a valid situation?
Actually, the short answer is that we don't do anything active, just as Han said. It is just the model have seen 50 petabytes worth of data. So it's have seen all sorts of scenarios in which the vehicle would respond in a certain way. So there's nothing explicit we have taught the model about these, right? Of course, these are video clips. I think we'll have to collect a lot more data to really understand this kind of behavior.
Okay, sounds good. I think one more question is, this is from students' perspective. What are the emerging technologies that students should focus on, and so that they can apply them to XPENG? Maybe Hang, you can take this.
Yeah, sure. I think like AI tooling is now super powerful. It can actually accelerate our work, and we can we have a faster way to implement our ideas and to try and to do experiments to scale up easily. And but I think that's a tooling that can improve your efficiency, but actually the actual like the experience and the way like you design the model and also to understand the problem, to solve the problem, still relies on the knowledge and the experience. And I think it's a very different way to work in the industry for now, but compared with a few years ago. But now I think it's actually a better time to learn how to use leverage this powerful tool. The key factor.
Cool. Thanks, Hung. I think the survey link is up now. I think few people had an issue saying it's suspended. By the way, my name is Manoj. Please make sure to leave a good feedback. I'm just kidding. We'll take one more question on the robotics side. There was one interesting question. Like, I think it was more about how do you achieve human-like movement, and also how did we get the human-like skin or something? That was the question.
You may so if I understand correctly, the first question is how we achieve like the movement, for example, the catwalk or the So so by the way, my background is more like on CVML, right? So this work is more about by our motion control team or embodied motion control team. So this is actually, as far as I know, so all this kind of motion trained using IR methodology, and we use simulations. The data we use simulation data and some like real data which actually is used to learn the style. For example, we want to mimic the catwalk, right? We have some real people to recall some catwalk gesture, and then combine them with kind of those simulated data. and one using the IO. I believe if you work on the motion control, like this kind of topic, you know it pretty well. So then when we have like, for example, model learned from the simulated data, we have to also like deploy to the real robot, right? There's some like a simulation and the sim to real gap, right? So our engineers has to close that gap. So this is how we achieve the catwalk humanoid, right? So and what's the second question? Second question is like the skin, right? This kind of robot skin. So for that question, actually, I don't have much idea. I think this is from our product and design team. Yeah, I cannot tell much about that. Sorry for that.
I think one more question on VLA 2.0. VLA 2.0 is cross-domain physical world model for cars, humanoid robots, and flying cars. Given that training data is very different, how do we approach the domain gap where the robotics and flying cars domain is completely different compared to the vehicles? Maybe I don't know if VLA 2.0 is a cross-domain model or is it just for cars? Siwan, do you want to take that?
Oh, sorry, again?
The question is VLA 2.0 model for cross-domain physical world for cars, humanoid robots, and flying cars? And if that's the case, how do we train? Because these are completely different domains.
Yeah, so there's different stages of training. First, the model really need to understand the physical world, right? So the base pre-trained part, it's just like you are going through your like language model is absorbing all the literature, right, with no specific task amount. That part I think is roughly the same. But afterwards, of course, you would have these fine-tuning steps and the reinforced learning steps. These things will be dependent on the domain application, right? On the whether it's a flying car, or it's a self-driving car, or it's a robotics. In fact, I think the base model likely will be shared, right? The base model will be shared between even robotics and autonomous driving.
Yeah, I just want to add to it. So basically, like we are actually work together on this kind of base models as we mentioned. So it is also used in robotics.
Thank you. I just want to make sure everyone is able to submit the feedback. Just raise in the chat if you have any concerns. We'll take a few more questions. If you have any questions, please post it in the chat group. Yeah, I think Hung answered this question, but I'll ask that anyways. But what kind of sensors are we using? Are we using LiDARs? Is a common question most people are asking. Any of you want to take? Yeah.
We are using all the cameras like around car, including the near field, like wide field of view, and also like the long distance, like all these type of cameras around the car. And also we are planning to use microphone to collect the audio, like the sound around the AV. And basically the intuition is like as human can drive really well, like to interact with the world. And also we can leverage the internet pre-trained open domain knowledge using the video and audio representation. And we believe is carries enough signal to solve autonomous driving problem. And then currently that's the current sensors we are using is only the like the video inputs, and we do not use any LiDAR or radar. And as like those sensors are, they bring some 3D geometry information. We also it brings a lot of noise, like for the input. And we believe that like if human can solve autonomous driving really well, and we can build this robust system using like the same sensor as a human.
Cool. There's a data pipeline question. So for training, do we just use teleportation data, teleoperation data, or large-scale simulated scenarios? And also, there was question about what is the mechanism we use for training for overseas. Do we just use simulated data, or have to go through the training once again for all the overseas models?
So, okay, I guess this question is for me. I was answering some question from the chat. So, I did not hear the first question, but for the second question, yes. So we rely. So most of the data we use for our motion control is from the simulation. But you know, as I mentioned earlier, so if you want to get some specific style, for walking style, right? For example, the catwalk, we have to collect those data from real people. This is, but that's not so. Like if you ask like the scale, for the real data, it's not that big scale. So yes, most of data we rely on the simulation. What's the first question?
I think you answered the question.
Okay.
Let me go through. Oh, this is interesting. I'm seeing it for the first time. Any exploration into moving into the improving the Python models with computing, quantum computing?
No, actually, I used to do quantum computing. I would love to do this, but I think this will be very, very far away.
Okay, yeah. Since US market has significant barriers for Chinese EV brands, how does XPENG plan to expand in the US? Will the strategy focus more on licensing technology, partnerships, or eventually selling vehicles directly? Who wants to take that? Maybe Siwan?
Yeah, so basically, currently there's no, I don't think there's a clear strategy to enter the US market, right? I think the car XPENG mostly focused on overseas markets, Europe, Southeast Asia, etc. So yeah, so these are the business questions, whether licensing technology partnership, etc. is so far the best I can say is as you from the news you know that there is a licensing partnership between XPENG and Volkswagen, right? Volkswagen would put a lot of technology on their cars. So this is almost yeah.
Oh, thanks.
Just want to add a little bit, like even though we do not sell the car to the US, but we do have a large office in both Silicon Valley and also San Diego, and we have like a few hundred of researchers in the US who work closely with the production projects and work with the Chinese team.
Yeah. But you certainly have opportunities to try your own product, whether it's in China or when you travel, or you know, there's in Mexico the cars will become available, so you have some opportunities to try your own product.
Okay, I think we'll take one last question. I see a lot of questions on the tech stack that we use. I don't know who can take that question, maybe from data pipeline and training, model development. Most people are interested on the tech stack and what skills and technologies people should be ready for.
Maybe I can give a little perspective here, right? In our recruiting process, my team, we are basically focused on basically have people, you know, folks with can think clearly, right? Have good foundations, and can learn fast, adapt fast, and is self-driven, right? These are qualities which we'll be looking into. Now, relating to specific technology stack, Han mentioned the ability to use AI to increase your productivity. Of course, the general knowledge about machine learning, architecture, you know, the MLSys, you know, training, the familiarity with basically the core of PyTorch, for example, all of these things, the understanding of for example, Ray stack, right? The understanding of MLR in compiler all this would be helpful depending on which part you are going into, right? Data statistics, data processing, knowledge of data lake and data system. This really depends on what you are applying towards. But in general, I think we are more focused, particularly for new graduates. I think there are a lot of emphasis also on basically on the foundation.
Yeah, maybe a follow-up question, Sivan. So, like there is a lot of AI buzz, at least at the university level, right? So, should students focus on like this agentic systems or focus more on fundamentals?
Maybe others can chip in as well. I think both are needed. The agentic system is now a way of working, right? But these are kind of also skills you can learn in industry pretty fast when you see. Now, the beauty of working in a place like XPENG or other tech companies is that you will see a very, very different environment, right, compared to in a classroom, because you have a lot of peers from somebody would, when you're doing things, they would look, step behind you and pat on your shoulder to say, hey, you maybe should do this way a bit differently, right? These are the real opportunity and the learning opportunity, basically working in a company with a high talent density.
Cool. I think we'll conclude the Q&A session. Just a few more seconds before you can scan this QR code. Like I mentioned, this will enroll you into the raffle prize that we'll be doing in a few minutes. Please make sure to leave your email address so we can send out the gift card. Thank you again, Sivan, Hung, and Jay, for answering the questions. If anyone has more questions, all of us will stay back after the entire presentation. So you can still send out the questions if you have any unanswered. So yeah, we'll spend a couple of minutes in terms of what XPENG can offer you and why you should choose XPENG. So I'll give this as a personal opinion. So we are working on like cutting edge technologies, but what we want is someone like you to join us and bring your ideas, and we can provide you state of the art infrastructure with huge compute power. And like some of us said earlier, we have petabytes of data where you can experiment your ideas. And we are a lab to market focused company. We want to deliver the features at a fast pace to the customers. It's not like we are researching for experimental sake. And in terms of career growth, at XPENG, we have some of the best scientists and subject matter experts working for us. And you will be rubbing shoulders with them and ideating and having discussions with them and be able to deliver features. It's not just the technical aspects, but all of our leaders are involved personally with each one of us to be able to grow our personal careers as well and suggest different paths based on our interests. Yeah, and in terms of culture, since we are a global company, we have colleagues and employees from across the world, who come with different experiences, and which is what makes it fun to work with them. And lastly, the support system that we have here. Again, personally, I am a person on visa. Immigration is a big thing for me. So I can assure you guys that we have a great support system. They go above and beyond in terms of visa, sponsorship, and everything, and so that you can focus on your work. And also, we have great perks like free lunch, free dinner, and our compensation packages are very competitive depending on where you are. And yeah, so I have blabbered a lot. I think we wanted someone with neutral perspective to share some, like Pinray is our recent intern. We wanted to share his experience so far at XPENG. So Pinray, are you here?
Yeah, I'm here. Thank you, Mano. Hi, everyone. I'm very excited to join today's sessions. My name is Pingrui Yu. I'm currently like a fourth year's PhD candidate in computer engineering at Northeastern University. So I joined XPENG early this year as a research scientist intern. Now I'm in the AGI model lab. So before XPENG, like most of you, like my work is mostly in the school, in the academia. So there's a lot of things that's mainly on like a paper or experiments. So one thing that really like stands out to me after I come here is that I realized how closely the work can connect to the real world problem. So when people ask me like, okay, what feels like when you're working in XPENG? I think these three things that usually comes to mind. So the first is the work itself, of course. So we have a lot of different teams and explore like different topics like VLA, world model, and foundation models. So these are things that you can often see in research in those papers, but here it also connect to the real product. So it feels like it's a really like interesting mix, like between the research and engineering, and you can really make a real impact instead of just like doing a theoretical test or theoretical like, experiments. And the second thing is the people and the culture. And the environment here, I would say it's really, really like collaborative and people are very low ego. So it means that here you can see that people are here open to discuss and the new ideas. They are willing to help each others. And for example, like my managers, and he's very supportive and he's very flexible with schedules. He's very like helpful and when I'm having trouble or when I have something like unclear. So which makes a really, really good environment for those new graduates or those people, so guys like me, like to grow, to learn. And there are also quite a lot of like a team and the company events. So it's honestly like really, really fun. And there's also like one detail Manon has already mentioned. There's a food here is pretty great and it's free. And you can order your own takeout and the company will reimburse it. So I think it's probably gonna be the best among the industry. Like so, yeah. So during the lunchtime, people just sit and talk and chat, having fun, and it's quite good, quite great. Okay, finally is the impact. And even as an intern, you had an end-to-end, you could have an end-to-end project and you could work with a really like strong engineer or the researchers and you can contribute to those like meaningful project just instead of just doing like theoretical research. So it's pretty good. So you can make a real impact. And there are also some opportunities like you can return for like full time. It's real. And which makes like whole experiments like very exciting from my perspective. I'm honest to say. So overall, like me personally, only like now it's only like 2 months. I really enjoyed my time here, and I wish if I can stay longer, I will. Like, so if you are interested in those kind of work and interested in XPERM, I'm definitely gonna recommend you to checking it out. And if you have any questions, please feel free to come talk with me. I'm here to wait for you this summer. Okay, thank you. I'll be around.
Thank you, Pinray. There are a few questions directed towards you. Maybe if you can respond on the chat, that would be great. So one last slide before we end this session. So at XPENG, I think this slide was not sufficient for us to even put the events that we did in last 1 year. We just cherry picked few. We value employee post work time a lot. So, and we do a lot of celebrations. Like recently, we had a Chinese New Year celebration where I personally had to got chance to experience the dragon dance and the cultural dance that they do. And our president Brian Wu was also here for that celebrations. And on the top right, we have our CEO Xiaopeng, who was here with us for our annual day celebration last year. And he's quite popular in China. And if you're lucky when you join, you will be able to meet him as well. I personally had a good conversation with him during the celebration. And on the right, we have family celebration where we went to Great America Parkway for a whole day. And personally, my son had a great time. And I want to say, like, again, that our CEO and the company emphasizes this a lot to have a good quality time with families. And also in terms of celebrations, we celebrate different festivals like Halloween, Diwali, Christmas, and whatnot. So everyone shows up and very open about celebrating different festivals. And in regards to wellness and sports, we have a gym facility in our nearby our office, and we do a lot of tournaments throughout the year, like badminton. This is one of the pictures from a tug of war from recent barbecue in the park party. And we also host a yearly ping pong or a table tennis tournament where I always lose. And there is one person who has consistently been winning for years. I would like one of you to join and beat him. And lastly, growth and support, like I mentioned earlier, as you can see, our VP, Shaming Liu, this was a fireside chat which we have frequently where our VP was, this session was mainly on career growth for interns, where he focused on how you should train yourself and build your career. Yeah, we have such sessions frequently. And also something like what we are doing, we usually host campus recruitment sessions. Like I said, so we are a company who's working on cutting edge technologies. We have a lot of work to do, and we would need some people like you to join us. And yeah, so please scan this QR code and follow us on LinkedIn, where we post our social media updates, product launches, and also open roles very frequently. So you can stay connected with us and be updated. So I think that concludes. Now is the time for the prize winners or the raffle. I would let Joanne, who is our partner, to conduct this raffle online. Hey, Joanne, can you hear me? Joanne?
Yes.
Yeah. Can you start sharing?
Sure. Oh, are you guys see the screen?
Yeah. Okay. So here's the raffle lucky draw. So what happens here is everyone who gave their email and name are enrolled here automatically. So let's go 3, 2, 1, start. Drum roll. Okay. These are the winners. We chose 30 lucky winners who will be getting $20 each. So please check if you're on the list. Joanne, if you can scroll a couple of times. So the prize will be sent to you via email in a couple of weeks. So expect email from us soon. Okay. Thank you, Joanne. If you can stop sharing, I'll conclude this. Okay. All right. Congratulations, lucky winners. This. One minute. Okay. Yeah, I think hope you all had a good, informative session, and hope we were able to share some insights into what we do as a company at XPENG. We can take a couple more questions. All of us will be here for 5 more minutes. So let me. Yeah, I think there was one question I missed earlier. What simulation software do we use? Because a lot of folks are on the simulation side. They wanted to know what is the simulation backend that we use. Who can take this? Maybe Hung, can you take it?
Oh, sorry, Manoj, I was distracted. Can you ask the question?
What is the backend for our simulation? What software or framework that we use is the question.
Right. That's a good question. So we highly relies on the the world model, like to reconstruct our scene and to predict the physical world and to use in the simulation environment. And yeah, we have our own like simulation platform and to do the self-play and to leverage the world model to enhance our VLA model.
Yeah. I think, yeah, I'm just going through the questions. I think there was a lot of questions about travel to China. I can answer that. I think we are open for travel. It depends on case by case. If there is a business requirement, I do see a lot of our colleagues travel to China and even Europe where we are expanding. So again, it depends on case to case. I don't see any new questions. If you guys have any questions, feel free to post the questions. Most of them are already answered, I believe. Yeah, I think there's one more question. Maybe Hang or Siwan, one of you can take this. I would like to know more about safety guardrails on the cars. This was also posted in pertaining to like the VLA demo that we shared. So how do we make sure our models are safe? Or yeah.
Yeah, so first of all, I think there is, we have a fairly sophisticated simulation system, right? We have to pass the safety bar in simulation. Then there's stages of release, basically. There's the early users, and there is, it's kind of goes up. There is all the standard things like you have a field test, right? Where, the test center in XPENG, they would basically create certain scenarios. For example, they will through a mannequin right in front of the car, this kind of test. So this is fairly standard.
Yeah. Maybe one last question. I don't know, Siwan, if you can take this, but what is the biggest challenge for flying cars at this moment?
Okay, I'm not a flying car expert, so although the foundation models we're building, the self-driving stack is also basically shared. I think if you look at the physical hardware, I think it is maybe the battery the most challenging one. I would argue, right? The range challenge and so on. But of course, it is an entirely different game of safety certification, right? It's entirely different. It's aircraft will take many years to certify a single release of anything.
Yeah. I think we'll conclude the question. There's one question about. Okay. So I think the question is already answered.
Okay.
Yeah, I think thank you everyone for joining. Again, I hope this information session was helpful, and we hope you consider joining XPENG. And like I mentioned, you can use the LinkedIn QR code that we shared earlier to follow. We'll be sharing a lot of job openings and media material consistently and frequently. All right. Have a good evening or good morning, wherever you're joining from. Thank you.